Hi, my name is Jesse Sathry, and I'm a developer for IBM PowerVP. Today I'll be walking through our new web interface that we've created for our latest version of PowerVP, version 1.1.3 that was released in June of 2015. So with the new version of PowerVP, it actually runs in a web browser now. So with the PowerVP installation media, it's now packaged as part of a WAR file. And along with the PowerVP WAR file, it also gets bundled with IBM WebSphere Liberty profile. And so you can either drop the PowerVP WAR file into an existing WebSphere server if you have one, or you can use the packaged server for your installation. And so this simplifies the use now so that instead of everybody having to install their own Java jar file to run PowerVP like in the previous version, now you can just deploy the single server and then have anybody that wants to use PowerVP just connect from their browser to that single instance. So with that little bit of background out of the way, let's hop in and take a look at what's new with PowerVP 1.1.3 and check out this new browser interface. So most of what we're going to look at today is probably going to look pretty familiar if you're familiar with the old PowerVP GUI. And just like before, we'll need to connect to a system. So up here, I'll use this new connection dialog. I already have my host name in there, username, and my password, and then I hit connect. And now it'll take a moment to connect to the system and download the data and start parsing it and get it displayed to our screen. So now it's got the data. Now we're seeing what's going on in our system, and just like I mentioned before, a lot of this should look pretty familiar to you if you're familiar with the existing PowerVP GUI. So going around the display here, just like before, we have our table of LPARs in our system. And in our table, we can see the LPAR ID along with a color that goes along with every LPAR. And we'll be coming back to these colors later, but they're used to identify the LPAR resources in the system layout for other views. We can see whether it's a dedicated or shared LPAR. We can see the number of cores entitled as well as the cores that are actually assigned. We can also see how utilized each of the LPARs are. So in this case, most of the LPARs are generally pretty idle, except it looks like LPAR 5. This dedicated LPAR with one core appears to be doing some work. So going around our display here, we have our host information up in the corner. So I can see that the system I'm connected to is Winter P6. And then I have my connection controls below that. And then I have my high-level system information, so I can see the nominal clock frequency, the total cores in the system, total processor modules or chips, the platform and processor generation. So just like the previous version of PowerVP, our new web version is supported on all the systems that our previous one was supported on. So we can use this to monitor any existing IBM platforms, IBM I, AIX, Linux, and it also supports all Power 8 systems and any Power 7 models that have firmware 7.7 installed. And then we also have some model and serial information, and then below that we have our overall system usage. So as we saw in our LPAR table, the system's mostly idle right now except for a single LPAR that's doing some work. So our system usage graph is pretty low. And then below that we can see our overall system core utilization as well as our overall system CPI. So CPI stands for cycles per instruction, and it's hard to give a good rule of what's a good CPI or what's a bad CPI. It's very workload dependent, but it can be used as a relative measure to compare system efficiency. And in general, you want to minimize CPI and it's very workload dependent. So But if you have if your CPI is going up, then you might have a performance issue to investigate. And then below that we have our actual measured frequency that we're getting in real time from the cores. And then below that we have our playback information, so we can see the timestamp of the data that we're viewing and the date according to the system that we're connected to. And just like our old GUI, our new one also behaves like a DVR. So we have playback controls down here where I can pause, rewind, fast forward in real time. And just like before, we can also record data and load data. And a new feature for our 1.1.3 version that I won't go into too much detail here since we're talking about the GUI, but we've enhanced the collection agent as well, so that you can configure your collection agent to always be collecting data in the background, and then you can use the GUI to specify a certain time, and then the agent will load data from that time and display it here. And then along with that enhanced data collection on the agent, we've also added a CSV Data Store so that you can configure the agent to also store data in a CSV format that can be loaded up and analyzed by any tool that interprets CSV data. And so continuing on our display here, so just like before, probably the main draw of our PowerVP GUI is going to be our system view over here in the lower right. So when we connect to a system, it will initially be showing us the hardware nodes in the system. And so in this Power 8 system that we're connected to, we have two hardware nodes, node 0 and node 1. And that's what we're seeing in our boxes here. So yeah, node 0, node 1. And within the nodes, we also have these other colored squares. So these colored squares are the chips within the node, and then the numbers on the chips are how utilized the chips are. So that's going to be the average utilization across all the CPUs within that chip. And the lines that are connecting the different boxes, those are the buses in the system that connect the chips. And one new feature that we've added to our web GUI for PowerVP is this toggle buses button. And so if I want to get more detail of which chips are connected to which other chips, I can press this toggle buses button, and then it brings the bus connections to the top, so I can see exactly where chips connect to the other chips in the system. Or if I'm not interested in seeing that, and I just want to hide the buses, I can press it again, and then I don't even see the buses. And so now from this view, all I see is the chip utilization. I get a nice clean view. But I'm going to bring that back to our default state where we can see the buses, but they're hidden behind the CPUs. So if I want to get a better look of what's going on within one of these nodes, I can just click it, and then it will expand the node in place. And so this is a nice little improvement from the old GUI, where before, if you wanted to expand a node, it would open up in its own new tab and be sort of isolated from the rest of our system view. So now with our web GUI, we can expand the node in place and still see what's going on across the whole system. And so now with node 0 expanded, we get a better idea of what's going on within that node. And so each of these large boxes in this view correspond to the green boxes that we saw on the previous view, or that we can still see on node 1. And so each of these are chips, and then within the chips are more boxes or graphs. And so these are our individual cores that are within the chip, and these will be sort of bouncing up and down a little bit as they're doing work. And so for the most part, these are mostly active, although they're sort of bouncing around a little bit, mostly in the idle state. Although we have one CPU that appears to be doing some work, and we'll be coming back to him in a little bit. But So we can see here also that the TPU cores within the chip are colored, and these colors correspond to our LPAR colors up in our table. So in this case, we can see that this first core belongs to LPAR 7 when I highlight over it, and there are 3 similar colored cores on chip 0. And so if I go up here to our table, I can see that that corresponds to LPAR 7, and that's a dedicated LPAR with 3 cores entitled and 3 cores assigned, but it's mostly idle. But if I come back over here and I want to see which LPAR it is that's doing all this work on this CPU, I can see that it's LPAR 5. And if I go up here to my table, I can see that that corresponds to what I'm seeing up here, where LPAR 5 is a dedicated LPAR with 1 core entitled, and it's approximately 75 to 80% busy, which is what we're also seeing down here. Now, some of our cores are just highlighted blue, and they have multiple LPARs in them if I highlight or if I hover over them. So these correspond to shared LPARs. And one of the new features that we've added to our PowerVP web GUI is that now we have this toggle affinity button. And I can press this, and I can see which physical cores our various LPARs are calling home for their vCPUs. So, so with the first 3 cores, that's a dedicated LPAR, and it completely belongs to LPAR 7, as we would expect. But now if I go over here to these other 3 cores, they're split up between different colors. And so I can hover over them and see which LPARs are having vCPUs that are calling that physical core home. And so just because it's calling that physical core home doesn't mean, it's not a guarantee that that LPAR is going to be dispatched there, but it's a good indication of where they're going to be trying to be dispatched if the system isn't overloaded. And so once I get done looking at my Affinity information, if I want to go back to see what's going on in the system for utilization, I can just toggle the Affinity back, and now I'm back in utilization view. And the other box to look at on this view are these mem boxes. And so this is our memory affinity information. And these have similar color highlighting that we have in other places of the GUI. And so, just like my affinity view where I can look at where my cores are aligned, I can get a similar view here looking at my memory affinity. So I can hover over it and see exactly how much memory each LPAR has on this chip's memory bank. And so here I can see that 25% of the memory on chip 0 belongs to LPAR 7. And that's that large area here, which corresponds to the color I have up in my table. And we also have bus information, that we, just like when we're on our system view with the nodes not expanded and I can toggle the buses, I can toggle the buses while I have the node expanded and get even more information. So if I press it once, it brings the buses back out to the top again, and they're all labeled. So I can see that my A2 bus connects chip 0 on node 0 to chip 0 on node 1. And I can see that I have an X bus that connects the chips within node 0. And just like before, if I don't care about seeing what my buses look like, I can just toggle those and then they go away. And the default is to see them, but to have them behind other things. And so then the final bit of information here when we have the node expanded is that I can also see our memory controller buses as well as our PHP buses. And if I don't want to see all this information in node 0 anymore, I can just click the node again, and then it goes back to the previous view. And then if I want to see what's going on in node 1, I can click that, and I can see that there's a whole bunch of green on node 1. And so if I hover over one of the cores, I can see that it looks like it's LPAR1 that's occupying this entire node. And if I go and look up in my table, I can see that node 1, LPAR1 is a dedicated LPAR with 12 cores entitled and 12 cores assigned, and it has that green color, so that matches up with what we see down here. So then if I take that back to the high-level view, and yeah, so that that's most everything from the system view in a nutshell. But then we also still have the LPAR view in our web GUI. And so if I want to open up the LPAR drill down, I can find an LPAR up in my table that has its name in this far left column. So if I click the row that has the LPAR filled in, now it will open up the LPAR view in a separate tab, and oops, I got out of there a little bit too early. So as I bring it up again, it's connecting to the LPAR, and we got to wait just a moment for it to start getting data. And now we're connected. So this view should be pretty similar to the LPAR drill down that we had in the old GUI, but we have a number of improvements that I'll be getting to in just a moment. So on the left side here, I have a lot of the same high-level LPAR information that we had in our old GUI. I have the name of the LPAR, whether it's shared or dedicated, uncapped or capped, the OS that we're connected to, entitled and assigned cores, CPI information, and then millions of instructions per second, which is sort of the inverse of CPI. So while we want to have a small number possible for CPI, we want this MIPS number to be as high as possible. And then you can also see the number of disk drives and Ethernet adapters. And then going down the display here, we can see the LPAR the CPU utilization of this LPAR, just like we had for the overall system utilization. We have a similar graph here for the LPAR, and then we also have similar playback controls and timestamp information. And then we have some controls here for marking the graphs, so I can press mark LPAR graphs, and it will add a line to all of our graphs over here to mark them at that specific point in time, in case I want to see what the graphs look like, make some sort of tuning change, and then see how it compares. And then I can just press the button next to it, and it'll clear the graphs again. So going over here to the right side to see what the graphs look like. So just like in the old GUI, we have our high-level usage graphs up on top. We have our CPU utilization, disk transfer rate, Ethernet activity, and then we have our load store unit CPI, our fixed point CPI, and our global completion table CPI. So these are all different sources that are contributing to our overall CPI. And so the load store unit CPI, that's one of the more interesting sources of information on this LPAR graph, or on this LPAR view. And so we have our detailed load store unit breakdown below our high level usage. So we can see here where we're spending time accessing information on our memory hierarchy. So I can see how much time we're spending on local L2, L3, on Power 8, L4, local memory, all the way out to distant memory. So L2.1 and L3.1, those are the L2 and L3 on different cores within the same chip. And then remote means that we're staying in the same node but going to another chip within the same node. And then finally distant means that we're crossing node boundaries and accessing data across the A-links. So in general, you want the most activity on these left-hand graphs. And if you're getting a lot of activity across the right-hand graphs, then you might want to look at how your LPARs are laid out and assigned, because it means that you might have some affinity issues, or it might be in your best interest to try to split up into smaller LPARs to try to minimize going across node boundaries. So then one of the big improvements on our LPAR drill down compared to the old GUI is that now we're showing all the graphs at the same time. So in the old GUI, we could only show load store unit breakdown or disk or Ethernet, and now we're displaying all the graphs at the same time. So if I go down below our LSU breakdown, I can see how much activity is happening across each of the different disks in the system. And then below that, I have my Ethernet activity. And so right now, this LPAR is mostly idle for Ethernet. And so yeah, since we're now running in a browser, any new LPAR connections will just be opened up in separate tabs within the browser. And if I can switch back and forth between tabs, so I can still just switch over and see what's going on in the system, or back over here to the LPAR. And if I get tired of looking at what's going on in the LPAR, I can just close my tab and it will disconnect from the LPAR. So that's our new web GUI for IBM PowerVP that shipped in June of 2015 with version 1.1.3. So thank you for watching, and please enjoy our tool.